Hello everyone, I am Samriddhi Kukre. In today's video, we are going to learn about gyroscopic couple, plus we will be solving one numerical on it. So before moving further, let's first understand what is a gyroscope. So in simple words, gyroscope is a device which helps to keep things steady and in balance. It works on the principle of angular momentum. Imagine you spin a toy top. It stays steady until it's spinning and falls when it stops spinning. Same is the principle of the gyroscope. It stays steady until it's spinning. Before moving further, let me ask you two questions. Have you ever wondered that why does a bicycle stay stable when it's moving but wobbles when it's stationary? And why do aeroplanes tilt when they take turn? So the answer to the first question is that when the bicycle moves, its wheels rotate and they act as a gyroscope. And same in airplanes. Airplanes have engines and propellers which act as gyroscopes. So let's now understand what is gyroscopic couple. So this is the figure. Let's consider this figure. In this figure, a disc is rotating in the plane xy on the axis of spin, that is OX. Let I be the moment of inertia of this disk and omega be its angular velocity. And let this axis of spin change to a small angle, that is del phi. And let the time taken to do this be del t. The below figure shows the vertical representation of the same. OA represents the angular velocity vector when the axis is OX, and OB represents the angular velocity vector when the axis is changed to OX dash. This change in the angular velocity is clockwise when we view from A towards B. This change in the angular this change results in the angular acceleration. Now the change in angular acceleration will be given as omega into del phi by del t. And usually del phi by del t, the angular velocity of the axis of spin is also called as the velocity of precession and is denoted by omega p. So the angular acceleration becomes omega into omega p. And the torque which is required to produce this acceleration is called as a gyroscopic couple or gyroscopic torque. And we can write it as I into angular acceleration. That is I into omega p into omega. This is the formula for gyroscopic couple. Now let's solve this numerical based on gyroscopic couple. Let's first understand what is the given data. We have been given diameter of the disc as 300 mm. We can find out radius from this. Mass is given as 5 kg. Moment of inertia is given as 600 mm. We need to convert it to meters, that is 0.6 meters, and RPM is given. So we all know that formula for omega, that is angular velocity, is 2 pi n divided by 60. So by the formula we can find out angular velocity. And now we need to find the moment of inertia. So the moment of inertia for the disk is given by mr square divided by 2. So by formula we found out this answer, that is 0.056. And further we need to find the gyroscopic couple. So for the disk it is given as mass into gravitation into its moment of inertia. So by the formula we found out the answer. We got 29.43 Newton meter. Now let omega p be the speed of precession. We all know that omega p is the speed of precession. We have seen it in the previous part of the video. So, and formula for gyroscopic couple is nothing but C is equal to I into omega p. So by this formula We need to put all the values. We have the value of gyroscopic couple also. We found out uh, before, that is 29.43. Then we have moment of inertia also. We have omega also, and we need to find omega p from this. So omega p from the formula came out to be 16.7 radian per second. Thank you.